Hi guys, Dave with First Place Auto Parts. Thanks for joining me in the studio today. Today's topic that we're going to cover has to do with anti-seize. And anti-seize is a product that we should all have on our shelves, but very few of us understand what it is, how to use it, maybe where we shouldn't use it, and the different types of anti-seize that are available. In today's show, we're going to take a look at all that, so stay tuned. And guys, if you find this video informative or you enjoyed the content, please consider subscribing to the First Place Auto Parts YouTube channel. There we will continually be putting up new how to install videos, new product review videos, and going to some pretty cool car guy events I'm pretty sure you're going to want to see. Before we talk about how to use anti-seize, where we shouldn't use it, the first thing we probably should understand is what anti-seize is actually made out of. And anti-seize is a mixture of a high quality base grease that has lubricating solids that are suspended in it. The solids can be copper, it can be graphite, it can be aluminum. All that has to do with heat, range, and also a lot has to do with the color, but also its application. But essentially, anti-seize is made out of a grease that has solids that are suspended or mixed in it, and that's ultimately what provides the lubrication. The grease is the carrier, and the solids that are put in it in very fine mixtures is actually what does the lubrication. Now at this point you might ask, why don't I just simply put grease on bolts to keep them from corroding? And you can. What grease does though is this starts to break down and actually burn off at around 400 degrees, where most of your anti-seize is good up to, in this case, 1600 or 1000 degrees. As that grease dissipates, what's left behind are the lubricating solids that are mixed in the anti-seize, which ultimately stays in place and is what protects and lubricates your threads. So anti-seize, much like grease, has a proper application where it could and should be used. There's also places where it shouldn't be used. We'll take a look at those later on in the video. Anti-seize is typically applied to the threads of a fastener to keep the threads protected from galling or from corrosion. Particularly in climates where you might have salt or salt air, salt water, say in the north where I grew up, we used to dread the corroded bolts, especially on suspension components, because some of those bolts were very large, and when the threads would swell due to rust, they were almost impossible to get off, in which case we had to cut the nut or split the nut to get the whole bolt out of the assembly. So anti-seize was something that I became familiar with when I grew up, and we used it on not only our vehicles, but our lawnmowers, our motorcycles, everything that had essentially a dissimilar metal going into another. So say you have a steel bolt going into an aluminum case, or a steel bolt going into, say, a spark plug going into an aluminum cylinder head. Those are dissimilar metals, they're predisposed to corrosion, and therefore anti-seize is that product that you typically want to apply to those things to keep them from sticking together. If you want to take a bolt apart at some point and it's either subject to salt air, or a lot of moisture, anti-seize is your answer. The first thing to know about anti-seize is to use this stuff sparingly. The goal of using anti-seize compound is to coat the threads with a compound preventing corrosion and adhesion between the thread and the fastener. Too much anti-seize applied to the thread can attract debris that may contaminate the threads and prevent the fastener from being removing cleanly or easily in the future. And when I say sparingly, it doesn't take much of this product on a thread to go a long way. Not only that, but if you get this stuff on your hands, I guarantee it, you're going to have this stuff everywhere. You'll have it on your clothes, you'll have it in your eyes, you'll have it on the piece of equipment you're working on. This stuff will stick and get on your fingers and be everywhere if you're not careful with how you apply it. So apply it sparingly, just a little bit goes a long way. We're just trying to coat the threads where the bolt will meet up with the point that it's attaching and actually creating clamping force. We're not trying to dress the whole bolt with anti-seize. Really, we're focusing on the area where the bolt's going to rest, where you start to actually tighten it down. So a little bit goes a long way, guys. The next thing that we need to know about anti-seize, and it's kind of forgotten sometimes, is that it's actually a lubricant as well. It's not just a protectant, it's a lubricant. So all bolts have a certain clamping force for a given project. Say it's 40 foot-pounds on a cylinder head or 100 foot-pounds for a lug nut. When you use anti-seize on a bolt or a stud or a nut, you're actually making the bolt easier to turn. Those lubricating properties will significantly decrease the required torque to achieve the desired clamping force. Using anti-seize without reducing the required torque value can strip the threads or stretch the bolt in extreme situations. And because anti-seize is a lubricant and it reduces the friction of the bolt going into its fastener, you have to reduce the torque values by anywhere from 20 to 30%. So whatever your torque value is, reduce that by 20 to 30% to get the proper application or clamping force. And finally, make sure you use the proper anti-seize for the proper application. There are different types of anti-seize. Silver anti-seize is stable up to 1600 degrees, while copper anti-seize is stable up to roughly 2000 degrees and has the additional benefit of its electrical conductivity. Nickel-based anti-seize is designed to be used with fasteners that must be kept free of copper contamination. Alright, now we understand what anti-seize is and the different types. Now let's talk about where not to use anti-seize. And the very first place not to use it, and we've all run into this, is when you've got some threads on say an assembly that's damaged. It might be a lug nut stud or whatever it is, and you just want to get that on. You're hurrying up, you want to finish the project. You'll deal with the damaged threads later. Some people may be tempted to put anti-seize on those threads just to help get that assembly back together. Do not do that. Do the right thing, tap, thread, chase those threads, make sure you fix it and do it the right way, or replace the bolt. You do not want that assembly failing on you unexpectedly, so don't use anti-seize as a crutch for bad threads. The second place, don't use anti-seize where there's truly lubrication needed, such as this brake caliper. There are pins and bushings that this caliper rides on as you apply the brakes that is meant to be lubricated. Anti-seize is not that product. It's meant for static assemblies, not sliding assemblies. It's a lubricant, but it's not made to have something that's continually moving because of those solid particles in it. So there's a specific brake grease that you want to use on those applications where the bushings and the pins that go through your caliper. Use the right product. Do not be tempted to use anti-seize for that. You're going to have a mess and it may seize up on you later with catastrophic results. And the final thing with anti-seize, don't use too much of it. Don't coat the whole thread with anti-seize. Like I said earlier, we want to get to the point where the bolt actually starts to tighten down on its stud, or the nut tightens down on the stud or its bolt. If you dress this whole thread area with anti-seize, what you're going to end up having is a lot of exposed bolt that has anti-seize on it, and this stuff is great at collecting and attracting dirt and dust. What's going to happen is that dirt and dust is going to fill those grooves. When you go to take this off, it's going to create its own kind of wear because you're going to have so much junk in the threads held on by anti-seize, which is pretty tenacious. It just doesn't wash off. So don't use too much of it. Don't be tempted to coat the whole bolt. All we're trying to do is to coat the area where that nut is going to actually rest on that stud or that bolt, where it's going to start to do its work. So where is the right place to use anti-seize? Good question, I say. Couple of things. The first thing is where dissimilar metals are present. The best case I can show you is on my motorcycles, my dirt bikes. There's an adjustment bolt for the chain tension that pushes against the axle. It's a metal bolt that threads into an aluminum swing arm that a lot of times will capture water inside. These things are notorious for seizing up and snapping off at the worst times. Very hard to remove. The other is, say, a steel spark plug shell and aluminum cylinder head. Another area where anti-seize makes a lot of sense. Just be careful, because remember, with spark plug holes, they don't require a lot of torque, and using anti-seize reduces the torque ratings on that. So you got to be careful when applying it to spark plugs, and you don't want to apply it to where the center electrode is. But again, any place you have a metal bolt going into an aluminum housing or aluminum bolt going into a metal housing where you have dissimilar metals and you can have galvanic corrosion, anti-seize can be your friend. The second thing is anywhere where heat would generate corrosion. Turbo housings, exhaust manifold bolts, header collector bolts. All these things are prime candidates for anti-seize use as well. Look, you may not take these things off with frequency, but when you do, you're going to be grateful that you had anti-seize on those bolts. And finally, anything under the car where it is subject to corrosion from, say, salt water or brine. If you live near the ocean, or if you live in the northern climates where they use essentially salt water to keep the ice off of the roads, your suspension components, the leaf spring hangers, things of that nature, are prime candidates for use of anti-seize. Again, if you ever want to take those things off in the future, I myself have tried to do this on an old 55 Chevrolet that I had. I literally went through 4 nut crackers to get the leaf springs off of that car because they were so big I couldn't cut them, and they were in a tough area. I had to split the nut to get them off of the actual bolt. Then I had to figure out how to get the bolt out. Use anti-seize on those things. One other place that makes a lot of sense, a lot of cars today have these under trays that are meant to streamline and increase fuel economy. What they do is make it a real hassle to change the oil. You know which one I'm talking about. Those little clips and those little bolts that you use to lower that tray or to open up that little flap, prime candidate for anti-seize. It'll make getting those things out a lot easier in the future. Reduces the wear and tear on the threads as well. Okay, hopefully now you have a better understanding of your options when it comes to anti-seize, where to use it, where not to use it, and how to use it. Make sure that you do have some on yourself, because I'll tell you what, while this stuff isn't magic, it's very good at what it does. Next time you go to take that bolt off, you're going to be grateful that you actually use this stuff. Just use it in moderation and you'll be okay. Guys, I really appreciate you watching this video. Hopefully you found it informative. We'll see you next time, and until we do see you next time, keep the hammer down and keep it between the guardrails.